We're going to graph a linear equation using a table. Now, when you graph a linear equation, it can be thought of as making a picture of the answer. So when you've got two variables like we have here, x and y, you can't there's not one single answer for x or one single answer for y, which makes it true. There there are an infinite number of combinations. So basically, in an equation like this, x can actually be any number, but it y can be any number, but they can't be, but they can only have one combination of the two. So, for instance, x can be one and y can be one, but in this case, you can't have x and y be both be one. If x is the number one, there's only one value that y will be able to be. So when we graph the equation, we're going to be drawing a picture of all the different combinations that will make this equation true. I hope that makes sense. But the way we're going to do this is by starting with a few points and plotting the points. And this equation is a straight line. So we don't actually have to find all of the points to be able to draw the picture. We just have to draw a few points, and it's always going to be a straight line that goes through those points. So this is how it's going to work. You start off by picking a number. One of the most important and confusing things for people to understand is that you can actually pick any number you want, because x can be any number. X can be any number, any real number. So any positive number, negative number, fractions, decimals, any number will work. But that doesn't mean that you should pick any number. I mean, there are certain numbers which will be easier to pick. And the idea when you graph this is to pick a number that is easier. And so I'm going to start off with 1 and with 0. Now, the reason I'm going to start off with 0 is because 0 is almost always going to be an easy number to choose. And the reason it's easy to choose is because it makes computation easy. 0 plus a number, like 0 plus 7, well, it's 7. That's easy to calculate. 0 times 7, 0. So any number plus 0 will just remain unchanged. Any number times 0 will turn into 0. And so that makes 0 easy to work with. So we're going to start off with 0 in this case, because that's the easiest one. The way you build a table is you start off with the equation. Sometimes instead of y, there will be something, it'll be written like this. And this is basically the same thing. You'll treat it the same way. We're not going to look at this right now. We're just going to use y and x, but you need two variables. So this is the dependent variable, this is the independent variable. We're going to pick a value for x, and we're going to replace x with that number. So we start out with that equation. Instead of x, we could just leave a blank space here, but I'm going to put parentheses. So this is where we're going to place the value that we've chosen. Like I said, any number. I picked 0. So I'm going to put 0 here. Now, once you replace that number here, all you do is you evaluate that expression. So 5 minus 0, evaluate means to do the calculations. So 5 minus 0 is 5. There's our first combination of x and y. So this is the y value. It goes under in the y column. The value we chose, 0, goes in the x column. Now we pick another number. Again, we can pick any number we want. Smaller numbers are usually better because they're easier. You wouldn't want to pick a large number in this case because, well, if we pick 15, for instance, notice the graph doesn't have enough space for 15. It goes up to 14. So that's an obvious one we wouldn't want to choose. So you want to pick values that will stay, that you can graph, that will be on your the scale that you have for your graph, and you want values that are easy to choose. So I'll choose 1. That should be easy to work with. So 5 minus, again, we leave a space. We've chosen 1, so we put 1 here. 5 minus 1, 4. That's our y value, so it goes up here, 4. Pick another number. I could pick 2. I'm going to skip ahead to 3 just for fun. So we have y equals 5 minus, again, we'll put it here, 3. 5 minus 3 is 2. And we have 2. And I'll pick one more. I'll choose 5. Actually, you know what? Let's just go ahead and pick a negative number. Show you that we can pick any number we want. So I'm going to pick negative 5. So now we have y equals 5 minus. Now the way you would replace a negative value is you put that in here. So 5 minus a negative 5, that's going to be the same as 5 plus 5. So 5 plus 5 is 10. That goes up here. Okay. You can pick any numbers you want. Now, negative numbers often are a little bit more confusing to work with, so you might not want to choose that. Maybe a positive 5 would have been easier. But for this demonstration, I'll do that. So 0, that's your x coordinate. That'll be the first term coordinate. Second term coordinate is the y value. So this one, x is horizontal direction, y is vertical. So up is positive, down is negative, to the right is positive, left is negative. So that's your positive direction to the right, negative to the left, down is negative, up is positive. So 0, 5, you move sideways 0, which is nothing. Up 5 is between 4 and 6, and you make your first point. Second point is 1, 4, that's over 1, up 4, like that. And we go 3, 2, and negative 5. We went backwards this way to the left. Negative 5, 10. Right there. Now, if I did this correctly, all of those points should be on a straight line. It's important to notice they're in a straight line. If your points are not in a straight line, it means you made a mistake somewhere. The two most common mistakes, if they're not all in a straight line, is that you might have graphed one of the points, one or more of the points incorrectly. So for instance, instead of doing 0, 5 right here, you might have gotten it switched around and done 5, 0 or 4, 1. Now in this case, that actually works out okay. But many times that will give you a point that's not on the line. The other mistake would be if you graph something, if you calculate incorrectly. So you check your points to make sure you plotted them correctly. And if you did, then check your arithmetic to make sure you did all the calculations correct. So that's 1 right here. This is the graph, y equals 5 minus x. And it looks like that. Now I'll do one more. Now this one, it's the same exact idea, but we have a fraction here, and fractions make people a little bit more nervous. So I want to spend a little bit of time talking about how you can make this one a little bit easier to calculate. especially if you're not using a calculator. So we're going to start off the same way. Pick 0 for the first term. That 0 is easy to calculate because even though we have a fraction, 0 times that fraction is still going to be 0. So when we replace x with 0, we end up with 0 minus 2, which gives us negative 2. So that's our first point. Okay. The second point, we might be tempted to use a small number because small numbers are often easy. Number 1, for instance, is an easy number to calculate because we get like this. 3/4 times 1 minus 2. Now 1 times 3/4 is very easy to calculate because 1 times any number remains unchanged. But we have a fraction minus a whole number or an integer combination, and that might bother some people. So if you don't want to deal with a fraction, here's a way you can avoid that. What we're going to do, instead of using this, we're going to skip ahead. And what we're going to do is look at the denominator and use that instead. So when we calculate this, we'll do it exactly the same way. We have a place for the number we chose, which is 4. Now when we do this, when we multiply fractions by a whole number, one method of doing it is to turn that into a fraction. Fractions you multiply straight across, and 3 times 4 is 12. 1 times 4 is 4. 12 divided by 4, to simplify, is 3. Now you might notice that we have a 4 and a 4 here, 4 in the numerator, 4 in the denominator. When we multiply that, we end up with 3 times 4 and 4 times 1. We can, instead of multiplying this together and then dividing, we can actually do the division first. And 4 divided by 4, that gives you a 1. Okay, so that cancels out. We're left with 3 divided by 1, which is 3, which is what we got here. So 3 minus 2 now is 1. So we end up with 1 here. Now, the next one, you might be wondering what number do we choose next? We're still going to use this 4. So what we're doing is we're actually counting by 4. So 0, 4. The next number will be 8. So 0, 4, 8. The next after that, if we chose another one, would be 12. So we're going to do this one the same way, almost. So we start out with 3/4. We replace the x with 8, and it's minus 2. Now the issue here is that when we look at 8 and 4, it may not be obvious that we can do some reducing with these. So we still have 3 times 8 over 4 times 1, but I want to represent that 8 in another way. 4 times 2 is 8, so instead of 8, I'm actually going to use 4 times 2. Oops. Now we have the same thing we had before, and we can cancel these out. We have an extra number on top here with the 2, so we have to multiply that. 3 times 2, 6 over 1, which is equal to 6. We still have that negative 2, so 6 minus 2. And that's equal to 4. Okay? So that's our answer. Now, we can do this a little bit faster than I did here, but I wanted to show every step. So what you would be doing when you do this multiplication here, 3 over 4 times 8, you say how many times we counted by 4 to get here, right? So we're going to use the 4. So 4 times what gives you 8? It's 2. So just cross that out. 4 times 2 here, 4 here. Cancel. 3 times 2, 6. So remember we had the 2 there before. Now 6 times 2, and the answer is 4. So we've got 3 points, 8 comma 4, 4 comma 1, and 0, negative 2. So 0, negative 2. 4, 1, 8, 4. If we wanted to use 12 also, we would say 3 over 4, 12 minus 2. Now we're going to break this up, and we want to know how many times does 4 go into 12? Well, it's 3, right? So the 4's cancel. 3 times 3 is 9, minus 2 is y. 9 minus 2 is 7. So this would be a 7. So we'd have 12, 2, 4, 6, 8. So 7 is right here. And that's the graph. Now notice, if instead of going over 8 up 4, I went over 4 and up 8, very easy mistake to make by switching the numbers around, I would no longer have a straight line. So if you have a point that doesn't go in a straight line with the others, check to make sure you graphed it correctly. Maybe you just switch the numbers around. If it's still not on the line, check your arithmetic.